Good afternoon and welcome everyone to IFC webinars. And today is a continuing series presented from the Fire Life Safety section on an introduction to low frequency audible alarms requirements in various codes and standards. And this is part two of a four-part series that we will be conducting through the Fire Life Safety section in collaboration with the National Home Builders and a bunch of other great people presenting. My name is Richard Miller. I'm an IFC SME and retired fire officer from Fairfax, Virginia. And I'm your host and moderator for today's event. Before we begin, audio is being broadcast using voice over internet protocol technologies through your computer, speakers, or headsets. Please make sure that your speaker and headsets are turned up and the volume is turned on. Audience microphones have been muted. If you experience any technical difficulties, please contact IFC support at webinars@ifc.org or via the chat function, which we will be monitoring throughout the entire presentation today. The chat and Q&A and handouts are available for everyone in the top right-hand corner. And please use the chat function to let us know who you are and who's on the webinar so we can communicate with you and welcome others to this event. And then throughout the presentation, please go ahead and use your Q&A to put the questions in. The presenters and I will coordinate all of those questions and make sure that everyone gets answered appropriately. And we'll have plenty of time at the end to go over those. And again, those handouts about the presentation will be available in the handout section. Some upcoming events at IFC. Fire Rescue Med here is just around the corner, April 30th through May 1st in Las Vegas. The Community Risk Reduction Conference in Glendale, Arizona is May 14th through 16th. As part of that event, we're doing a pre-conference event for low frequency alarm, sponsored with the National Home Builders Association and a lot of other people looking at all these various topics and issues related to low frequency alarms. And that's on Monday, the 13th and 14th for this information. And we'll continue to work and post information available about this great interest. The next big activity is June 5th and 9th in the Hazardous Materials Response Team Conference in Baltimore. And again, that's a great event for hazmat teams and others to come. And then in August will be Fire Rescue International, August 14th through 16th in Dallas, Texas, which is a great venue for FRI. So we look forward to seeing you there, and hopefully you can join us. Today, as part of our activity, this is part of some of our activities that we're gathering information, scooping up some stuff, looking at the technologies, looking at the future of research, what some of the devices are in the various systems. And then we have great experts here, and you're going to meet two of them here in a second that are going to present today's event and provide you with some really great resources and information. So as we do that, first I'd like to go ahead and introduce Corey Ogle. Corey is the Director of Design and Code Consultants, and he has a BS in Electrical Engineering. He's a licensed fire protection engineer in 5 states, has over 25 years experience in the industry. He's the chair of the NFPA 72 Technical Committee, a non-voting member of the 72 Correlating Committee, and a member of several UL standard technical panels. And serves on AA, SFPE, and NFPA member. So he's got quite a litany here of background. And then our second presenter is Richard Roberts. Richard's also a member of the Fire Life Safety section, providing a great resource to the chiefs. But he's a senior industrial affairs manager at Honeywell Fire Safety with over 30 years of experience in installation, sales, commissioning, and project management of code-compliant commercial fire alarms, carbon monoxide detectors, emergency communication, and security systems. Mr. Roberts is responsible for code and standard development at the federal and state level, as well as legislation. Mr. Roberts is currently a member of the NFPA, UL, ICC, and ISO committees, as well as serving as the board of director for the Industrial and Fire Life Services organizations. And I said earlier, he's a board member for FLSS. So it's with great pleasure that I'm going to turn over the presentation now to Corey, who's going to lead us off today with our events. So Corey, over to you, sir. You're muted, Corey.
Sorry, it'll be Richard starting off.
Oh, sorry. Okay. Richard, over to you then.
All right. Well, thank you, Chief Miller, and welcome everyone. Really appreciate everyone taking time from your busy schedule to attend today's presentation. I also would like to thank the Fire and Life Safety section for giving Corey and I this opportunity to speak. And I also really appreciate the opportunity to be a co-presenter with Corey. And what we're going to do is provide an overview of the requirements for the 520 hertz low frequency audible alarm signal in the various codes and standards. And as you can see, we'll start by covering the various reports that show how smoke detection has reduced fire fatalities in the last 35 years, which I'm sure we all know, but it's always good to hear again. But even though we've seen significant reduction in fire fatalities, challenges remain, and then we will start to review them. And these challenges are really the reason for the low frequency requirements that were inserted into NFPA 72, several UL product standards, as well as ICC and NFPA model codes. Then we really want to kind of wrap the presentation up and look at the sleeping areas that are required to install the low frequency audible alarm signal, and probably more importantly, the sleeping locations that are not required to have the low frequency signal. And then, of course, we will get into it may not necessarily be that new, but probably within the last 2 or 3 years, there's been some changes to ICC and NFPA model codes that relate to this. Um, just a couple housekeeping slides here. I'm sure Corey will, concur with this, but this is my Honeywell legal disclaimer. Yes, I'm on the NFPA 72 Chapter 29 committee on various NFPA 101 and NFPA 1 committees, very involved in the ICC process. But the comments and opinions expressed today are mine only. They do not represent the official position of the National Fire Protection Association, the International Code Council, Underwriters Laboratories. I think that that's really important to stress. So let's get started with the presentation. It's really been well documented that smoke detection has helped reduce the number of fatalities in dwelling units and buildings in the last 35 to 40 years. And according to numerous NFPA reports, home fire fatalities in the U.S. have decreased from slightly over 6,000 in 1978 to a little over 2,600 back in the mid 20 teens or 2015. And if you stop and think about it, that's an overall reduction of 44%. Now, NFPA classifies homes as detached 1 and 2 family dwellings, manufactured homes, or multifamily housing. Now, as it relates to non-home fire fatalities, they have decreased as well. According to a U.S. Fire Administration study, non-home fire fatalities declined from 640 in 1977 to 120 in 2011. And looking at hotel and motel structure fires, fatalities have declined there as well, as you can see, from 62 in 1980 to 16 in 2010. Now, what I find really interesting is during this same time period that we're seeing all these significant reduction in fire fatalities, the U.S. population actually increased by 97 million people. Now, it's important to point out that not all the reduction in fatalities can be attributed solely to the use of smoke detection in fire alarm systems. but virtually all researchers and code authorities agree they have contributed, that being smoke detection, to the substantial reduction. So, really, the takeaway here is that more than 90,000 lives have been saved since the late 1970s. And that's when the model codes first began mandating the installation of smoke alarms to be installed in certain occupancies. So, as I said a minute ago, even though we've seen significant reduction in fatalities, challenges remain. For example, there are several factors that limit an occupant's ability to safely escape from a threatening fire, even if the fire alarm system or the smoke alarms are operating properly. The amount of time people need to safely exit a dwelling unit or a building is one factor. Now, escape time is measured by RSET and ASET. RSET involves estimating the time it takes people to exit the structure through the normal path of egress once they are aware of the emergency. Whereas ASET, okay, that is the time from the detector activation or the fire alarm activation until the start of unattainable conditions. And these conditions will prevent people from safely exiting the occupancy. A couple of these conditions are visibility. When the visibility from smoke is less than 20 feet, temperature, it's above 140 degrees Fahrenheit. And lastly, when carbon monoxide concentrations are above 800 ppm for a short period of time. So the takeaway here is people will have less available safe egress time, or there is less available safe egress time. The second factor is how effective is the standard audible fire alarm notification signal at waking up all people, but most importantly, high-risk segments of the population during a fire. And the challenge to overcome is for these high-risk segments of the population to hear the audible fire alarm signal, wake them up, and so they're able to safely exit the dwelling unit. Now, when I say high-risk segments of the population, that is school-age children, people who are deaf or hard of hearing, people who are alcohol or shall we say chemically enhanced, and also the elderly. I'm 63 years old. I am getting to the age where a person's natural hearing ability, they lose the ability to hear a high frequency signal, but they're still able to hear the low frequency signal. So, why have escape times decreased in the last 35 years? Well, number one, the type of interior furnishing found in homes, hotel guest rooms, dormitories, offices, they have changed quite significantly. For example, man-made synthetic materials have replaced natural materials used in furnishings. If you go back 40, 45 years ago, virtually all interior furnishings were made of natural materials like cotton, wood, wool, linen, or silk. Most furniture available today utilizes polyurethane foam for padding, polyester or nylon for furniture coverings, carpet, and drapes. And the reason for this transition to synthetic materials is because it's less expensive, easier to clean, and more resistant to normal wear and tear than natural materials. But with the widespread use of all these synthetic materials, fires today are considerably different than they were in the 1970s. There are numerous reports that show how synthetic materials ignite and burn faster and hotter than natural materials used in the past. But most importantly, these reports, which we'll get into in a minute here, show that people have less available safe egress time today than what they did back in the 1960s and 1970s. And that's because of the use of all of this synthetic materials. So the two most notable studies that document how people have less available safe egress time today, and that's due to the widespread use of synthetic materials, were conducted by the National Institute of Standards and Technology, typically referred to as NIST. Now, the first NIST study conducted a series of full-scale tests, full-scale burns, from 1974 to 1976 in homes that were scheduled for demolition as part of the expansion of the Indiana Dunes National Lakeshore Project. Now, this report is commonly referred to as, that's right, Dunes 1, and it used homes that were constructed of real wood lumber and interior furnishings made of natural materials. Like I said, cottonwood, wool, linen, and silk. Now, the study concluded that people had 17 minutes of ASAP, available safe egress time, in a flaming fire, and that smoke alarms back in the 1970s provided adequate escape time in 90% of the fires. Now, 35 years after the original Dunes 1 research, NIST conducted a similar study, except the interior furnishing and the building materials were made of modern synthetic materials, and it used more advanced, sophisticated instrumentation to monitor and record the data. Now, this second NIST study is commonly referred to as Dunes 2. And it confirmed that new synthetic furnishings and building materials burn hotter and faster than fires in the 1970s. Another important finding is that the available safe egress time in a flaming fire has been reduced to only 3 minutes compared to 17 minutes in the original Dunes 1 study. Now, NIST did note that early detection of these fires is critical to allow occupants to safely exit a dwelling unit or a building. And most importantly, the study concluded that properly installed and maintained smoke detection devices still provide enough escape time in most fire scenarios. Now, to really get the impact of the difference between a legacy fire and fires today, UL has conducted and recorded 2 full-scale fire tests to illustrate the difference, okay? And you can find this, and I believe that this web link here at the bottom is still active, but you can go to YouTube and actually see these fires live, and it's actually quite shocking. But during the next several slides, we'll show some screenshots of the different stages of the 2 fires. Oops, excuse me, here we go. So the setup of the test, both rooms measure 12 foot by 12 foot with an 8-foot ceiling and contain similar amounts or quantities of light furnishings. The legacy room on the left contained furnishings made of natural materials, whereas the modern room on the right contained furnishings made of synthetic materials. And fires were ignited in both rooms by placing a lit candle on the right side of the sofa, right over in this area here. And the fires were allowed to grow until flashover. So let's go to the next slide. So as you can see, at 1 minute, 30 seconds, the flames in the modern room are clearly visible, whereas the fire in the legacy room is just beginning to show a slight sign of a flame. And going to the next slide, at 2 minutes, 30 seconds, the fire in the modern room is, as you can see, is growing rapidly, and black smoke has covered the ceiling. And the flames in the legacy room are really becoming more available. You can see it quite clearly. Now, at 3 minutes, 30 seconds, the modern room has transitioned to flashover. And of course, we all know flashover, when that occurs, nobody is getting out alive. But the flames in the legacy room are still not that prominent. You can see that, but it's not a roaring fire at that point. And I should say that the legacy room does not transition to flashover until 29 minutes and 30 seconds. So you can see here, this is quite amazing when you look at this, and especially if you go online to YouTube and see that video. It's actually quite shocking. So at this point, I think, Richard, Chief Miller, do we have any questions? And if not, then I think it's time for Corey to impart his wise wisdom.
No questions in the queue, but I'd like to encourage our participants to go ahead and post those questions. But some great connection there to the escape time and modern buildings and the change. That's some really good information, Richard. Thank you.
You're welcome. Corey?
All right. Thanks, Richard. I hope at 63, I'm still as sharp, handsome, and spry as you are.
Oh, God, stop it.
All right. So why low frequency? According to the USFA report on civilian fire fatalities in residential buildings, 50% of fire fatalities in residential buildings occur between 10 p.m. and 6 a.m. or overnight while most people are sleeping. That's the study referenced on the screen there. That study is from 2008 to 2010, but it still holds true today, right? The 2017 to 2019 report has the same results. 50% civilian fire fatalities in residential buildings occurred in bedrooms, and 49% of civilian fire fatalities occurs between 11 p.m. and 7 a.m. or overnight. In 2008, Thomas and Bruck published the results of a decade-long study researching the waking effectiveness of various smoke alarms for awakening sleeping people. The study found that most unimpaired adults with less than mild hearing loss will normally awaken to their temporal 3 or 3 kilohertz smoke alarm sounding, even at levels well below 75 dBA. But what about the vulnerable or at-risk population that Richard mentioned, such as children, adults impaired by alcohol, adults over 65 years of age, or people with at least mild hearing loss? Unfortunately, the at-risk population seem to make up a significant portion of these civilian casualties in residential fires. So what can be done to help this at-risk population? Low frequency, right? So the same Thomas and Bruck study mentioned before found that a 520 hertz square wave sound was the most effective of the sounds tested and awoke most and often all of the participants in the study, even those that did not wake up to the current 3 kilohertz signal at 95 dBA at the pillow. Very loud 3 kilohertz signal sound. The 520 hertz was found to be 6 to 10 times more effective in waking children, young adults with a BAC of 0.05 or less, and older adults with no hearing loss, and was found to be more than 6 times as effective in waking adults with hearing loss. This study also found that voice alarm was quite effective for younger age groups, but not for older adults or those with limited English, and found strobe lights to have a very poor waking effectiveness across all groups. So in 2006, 2 additional studies were commissioned by the Fire Protection Research Foundation to study the effectiveness of these different signals in waking 2 of the high-risk groups, those with hearing loss and those impaired by alcohol. And by the way, these studies referenced here are public and are just a quick Google search away if anybody is interested in reading them in their entirety. Both studies use the same 6 different test signals, including sound, tactile shakers, and strobes. All 6 signals used the temporal 3 pulse. Each signal was presented for 30 seconds, followed by a short 30 to 70-second period without signal, and then at a higher intensity level that continued through a set range or until the participant awoke. So the conclusions, right? Both studies concluded that a 520 hertz square wave T3 sound was the single most effective signal, awakening 92% of the hard of hearing participants when presented at or below 75 dBA, and 100% of the participants at 95 dBA, and 93% of alcohol impaired participants at 75 dBA or less. In contrast, the current standard of 3 kilohertz T3 at or below 75 dBA was effective in awakening only 56% of the hard of hearing participants and 61.5% of the alcohol impaired participants. Tactile shakers were effective in awakening approximately 80% of those with hearing loss and approximately 60% of those alcohol impaired participants, with the participants 60 years or more being less likely to awaken. The strobe lights were only 25% effective for both groups of participants. So based on this clearly increased effectiveness, there was a push to get 520 hertz square wave or low frequency into the codes and standards like NFPA 72. So what does NFPA 72 say? NFPA 72, as most of us know, is the National Fire Alarm and Signaling Code, and is traditionally thought of as a how-to code, right? The ICC and NFPA model building codes deal with the when and where, and to some degree the what, which Richard will touch on in more in a minute. But once you know what type of fire alarm system is required, NFPA will tell you how to meet those requirements, including low frequency. First introduced into the 2010 edition, these low frequency requirements are primarily detailed in 3 chapters. Chapter 18 focusing on notification appliances, Chapter 24 addressing emergency communication systems, and Chapter 29 dealing with smoke alarms and household fire alarm systems. Chapter 18 requirements are applicable for occupant notification when connected to building fire alarm systems not covered by Chapter 29, which includes single and multi-station smoke alarms and household fire alarm systems. These separate requirements can get confusing for certain residential occupancies, where a building fire alarm system and single and multiple station smoke alarms are required and installed. They are 2 separate sets of requirements. So 18453 mandates that audible appliances in sleeping areas shall produce a low frequency alarm signal. This signal, whether a square wave or equivalent, must possess a fundamental frequency of 520 hertz plus or minus 10%. This provision aims to ensure effective awakening ability for occupants, especially those who may be asleep. Even though this requirement was introduced into the 2010 edition, an effective date of January 1st, 2014 was included to allow time for product to become available. The 2010 edition of NFPA 72 didn't really define a sleeping area, but did have a definition for a separate sleeping area, which is the area of a dwelling unit where the bedrooms or sleeping rooms are located. As you can imagine, this definition is a little vague and doesn't necessarily include all areas where a sleeping person may be found. Chapter 24, section 24.4 in particular, deals with one-way emergency communication systems. 24.4.1 deals with in-building fire emergency voice alarm communication systems, or EVACs, right? Voice evacuation systems. Originally in the 2010 edition, section 24.4.1.4, a lot of numbers, basically stated that if you have sleeping accommodations in your occupancy, then the pre-tones before the message must be the 520 hertz square wave. However, this was all updated when TIA 10-4 was issued in March of 2010 and further clarified these requirements to only apply in occupancies where sleeping accommodations are provided and the voice message is intended to awaken people and only required in the areas where people may be asleep. So on to chapter 29. Chapter 29 deals primarily with single and multi-station smoke alarms and household fire alarm systems. Because this chapter primarily deals with single and multi-family homes, the approach to when low frequency is required is different because it's difficult to enforce requirements within someone's home. So Chapter 29 primarily relies on residents to self-identify as having mild to severe hearing loss. Section 1A up there indicates where required by other governing laws, codes, or standards in case your building or occupancy does have a requirement for a certain number of rooms to be set up or provided with people with mild to severe hearing loss, which is defined in NFPA 72. 2013 edition, slight changes, including the term to awaken adults in Chapter 18 with the same effective date. Similarly, Chapter 24, slight changes to the wording that was found in the 2010 TIA, which became the base code for the 2013 edition. And there were no real changes to Chapter 29 in the 2013 edition. 2016 edition removed the effective date, right? Past the date, 2016 edition should be product available to meet Chapter 18. Means that anytime this 2016 edition is accepted and enforced, low frequency notification appliances are required in sleeping areas. And in the 2016 edition, there were no changes to Chapter 24 or Chapter 29. 2019 edition saw no change to Chapter 18 or Chapter 24 requirements, but did see one small addition to Chapter 29, which put the responsibility of determining the hearing deficit on the person with the hearing loss. The 2022 edition, the term separate was removed from the definition, and the definition itself stayed the same. Otherwise, no changes to Chapter 18 or Chapter 24. So, in addition, NFPA 72, UL standards do exist to address low frequency requirements. For instance, ANSI or UL 464 mandates that low frequency notification appliances complying with specific sections be clearly marked as low frequency alarm or low frequency sounder. Similarly, UL 217 requires smoke alarms with low frequency alarms to be labeled accordingly. Right? These test protocols are necessary to ensure the products being installed meet a rigorous set of design, production, and operational standards. As chapters 18, 24, and 29 all state, the equipment being installed shall be listed for the purpose in which they are used or intended, which is defined in Section 325 of NFPA 72. If there are any questions, otherwise, Richard?
So we did have one question that came in, and I posted a quick answer. Is about where will all this information be available. As we conclude the 4 series of webinars and then the in-person symposium, we'll be building a landing page for all of this information through the ifc.org site, and you'll be able to gain that. And we will be sending out a notification once that site is up and available to all of the webinar participants. So great question. And yes, we're trying to provide you with that relevant information. So I'll pass it back on to you all.
All right.
Okay, I guess it's my turn to speak. So let's turn our attention and look at the low frequency requirements that were added to the ICC and NFPA model codes. Corey did an excellent job providing an overview of the requirements in NFPA 72. But let's look at what the model codes have to say. So if you look at, the IFC or the IBC, all right, Section 907.2 requires fire alarm systems to be installed in new buildings in accordance with NFPA 72 and provide occupant notification in accordance with Section 907.5. And of course, 907.5 requires the activation of a fire alarm system to send a signal to the control unit and then provide occupant notification throughout all occupied areas of the building, including both common and tenant spaces. Of course, common spaces would be interior corridors, lobbies, or meeting rooms. Tenant spaces are dwelling units within apartment buildings, guest rooms within hotels, or dormitory sleeping rooms. And of course, the purpose of the fire alarm system or the smoke alarm is to alert occupants of a fire. So, if you look at the IFC, the IBC, back in Chapter 35 of the Building Code, it provides a list of all of the reference standards. And of course, NFPA 72 is one of those reference standards. So just a little review of 72. The low frequency audible alarm signal is required in hotel guest rooms, dormitory sleeping rooms, dwelling unit bedrooms within apartment buildings, in these occupancies that have a protected premise fire alarm system. However, the low frequency signal is not required in occupancies where the occupant notification system is used to communicate to occupants who are awake. Several examples here are hospitals, jails, or other occupancies that have trained staff on duty 24/7, 365 days a year to take appropriate action, such as waking or possibly relocating patients who could be in danger. However, if you look at Chapter 29 of the NFPA 72, as Corey said, smoke alarms are not required to produce the low frequency when they are installed in hotel guest rooms, dormitory sleeping rooms, or dwelling unit bedrooms of apartment buildings. And, that's because, as Corey said, most of the time, alarms are installed in detached 1 and 2 family dwellings in townhomes, not more than 3 stories. But, in hotel guest rooms, dormitory sleeping rooms, all that, that could create a little bit of a challenge. And let me provide an example here of this. So, I'm going to show 2 floor plans that will illustrate the different requirements within NFPA 72 and how it creates a potential life safety issue. The first application here is a floor plan of a hotel, or it could be assisted living facility or a dwelling unit within an apartment building. These buildings are required by the code to have a fire alarm system that uses voice evacuation for occupant notification. The guest rooms or the dwelling units that utilize smoke detectors with the low frequency audible base and speakers for occupant notification. In accordance with Chapter 18 of 72, both the smoke detector sound of the base and the alert tone of the speaker are required to produce the low frequency signal. However, what if you're using smoke alarms in these sleeping areas instead of smoke detectors? Now, the unit on the right here is an ADA unit. And in accordance with Chapter 29 of NFPA 72, the smoke alarms that are installed are not required to produce the low frequency signal. However, Chapter 18 requires all audible notification appliances connected to the fire alarm system to produce that low frequency signal. Okay. Now, for this application, if you stop and think about it, and I always give this example, this could be, an apartment building, or let's just say a hotel. If a fire starts in the interior corridor of the hotel, you have smoke detectors there. They will detect a fire, send a signal to the control unit. The control unit will then activate the audible notification appliances that are connected to the fire alarm system. It'll activate them in each hotel guest room. In Chapter 18 of 72 requires that notification appliance to produce the low frequency signal. However, if the fire starts out in that hotel guest room and there's a smoke alarm in there, it is not required to produce that low frequency signal. And that's because of the requirements that are found in Chapter 29. So in a hotel guest room, you really have two types of signals there. You got the low frequency that is produced by the fire alarm system and the 3 kilohertz tone that is supplied by the hotel guest room. So back in the 2021 edition of the International Fire Code and the International Building Code, new requirements were added. As you can see, 9075213, audible signal frequency in group R1 and R2 sleeping rooms. R1 being hotels, R2 would be apartment buildings or university dormitories. And the audible signal frequency in R1, R2 occupancy shall be in accordance with 90752 and 132. Well, what does 131 have to say? Well, it says the fire alarm signal system, fire alarm system, system signal. Boy, that's a tongue twister. And really, this is not a new requirement, and that's because NFPA 72 Chapter 18 requires the system to produce the low frequency signal in the sleeping areas of R1 and R2 occupancies. But this requirement was placed into the fire code to make sure that it is crystal clear. Looking at this next section, 90752 smoke alarm signal in sleeping rooms of group R1 and R2 occupancies that are required to have a fire alarm system. Well, in this case, the audible signal activated by the single or multiple station smoke alarm in the dwelling unit or sleeping unit shall produce the 520 hertz low frequency signal. But this section goes on to say where the sleeping room smoke alarm is unable to produce the 520 hertz low frequency signal, the signal shall be provided by a listed notification appliance that is connected to the fire alarm system or a smoke detector that is provided with an integral 520 hertz sounder. Now, looking at the 2021 edition of NFPA 101, basically they have the same requirements there, but they are worded a little differently, and that is because the format of NFPA 101 is different than what you find in the IFC IBC. Now, even though they're the same, let's just take a quick look at the requirements in NFPA 101. In Chapter 9 of NFPA 101, that is your core chapter. And that's what your occupancy chapters, which are 11 through 43, will refer to. But in the core chapter, In new construction, where required by chapters 11 through 43, the alarm notification signal in sleeping rooms resulting from the activation of smoke alarm shall be the 520 hertz low frequency signal. This next section here, where required by chapters 11 through 43, the audible notification signal provided in sleeping rooms resulting from the activation of a fire alarm system or sleeping room smoke detector shall produce the low frequency signal. As I said, this one here, 9633, really is not a new requirement because Chapter 18 of NFPA 72 already requires this, but we all thought it would be best to also put that into the code. Now, what do the occupancy chapters have to say about low frequency? Because these two requirements really mean nothing until an occupancy chapter provides a trigger back to Chapter 9. So looking at Chapter 28, this is for new hotels and dormitories. So in new hotels and dormitories that are required to have a fire alarm system, the audible notification signal provided in sleeping rooms of guest rooms or guest suites that is activated by the fire alarm system shall be what? The 520 hertz signal in accordance with 96210.3, which we just reviewed. But 28.3.4.6.1 in hotels and dormitories that are required to okay, the fire alarm, all right, the smoke alarm here shall produce the 520 hertz low frequency signal. All right, and that is if the hotel or dormitory is required to have a fire alarm system. Changing gears to apartment buildings, same requirements as in hotels, all right? Apartment buildings that are required to have a fire alarm system. The fire alarm system shall produce the low frequency signal. In apartment buildings that are required to have a fire alarm system, the audible notification signal provided in sleeping rooms that is activated by the smoke alarm shall be the 520 hertz low frequency signal. So I think that gives a good overview of the history behind the low frequency requirements, the research, and a look at the requirements, how they have evolved in NFPA 72 and in the ICC and NFPA model codes. So with that, I will turn it over to Chief Miller to see if we have, any questions at this point.
Great, Richard, Corey. This has been awesome. Some great information. And again, it's I'm just retired, so it's just Richard. There is a good question here about the listings in UL. Can we post the actual listing number for UL for low frequency alarms and where that resides?
Yeah, we can. That's sorry, Richard. That's UL 217 for single and multi-station smoke alarms.
Excellent. There you go. That answers one question. The next question that we had pop up is low frequency alarm requirements for smoke alarms in the IBC and IFC 2021 included for care facilities.
Great question. In the 2021 edition, care facilities are not addressed, but for the 2024 edition, I think it's I1 or I2 occupancies are required to produce that low frequency signal, and that not hospitals because you have trained staff there, but I think it's I2 occupancies which would be more in line with an assisted living facility. But that would be the 2024 edition of the IFC IBC.
Great. So going back to the use groups and looking at the code to determine that. So like the follow-up question was in the group home. So I think you just covered that right there with the those requirements. So again, looking to the 2024 standard for that guidance. So that's good stuff. I think this has been an outstanding presentation today, and I look forward to continuing the conversation. If anybody has any other questions, please go ahead and post them into the Q&A. As we close out today, we'll certainly be tracking those questions and making sure that we answer those, and it'll be brought back up in the actual symposium. And again, if you're available, there's still slots available at the Community Risk Reduction Conference to attend the symposium as well there in Glendale, Arizona in May. So I want to just give Richard and Corey a quick second here to kind of, any closing thoughts as we wrap up today's presentation.
Thank you, Richard. Sorry, I'm just accustomed to saying Chief Miller, but I will say one thing though. At this time, there are no smoke alarms that's on the market that can produce that low frequency signal. I am expecting one manufacturer to probably come out with a product sometime this year, but it's and the smoke alarm manufacturers, they've got some real challenges with designing a product. A little bit easier of a challenge than for fire alarm systems, but nonetheless, I'm sure that they're all working on it, and there should be product available later this year or next year. But a lot going on in this area. I can't speak for Corey, but for me, if you ever have any technical questions, you have my contact info on the last slide, and don't hesitate to send me an email. So with that, I'll turn it over to my esteemed chair for the Chapter 29 NFPA 72 committee, Corey Ogle.
Thanks, Richard. I agree with your comments. We hope and expect product to be available soon. There are also changes coming in the 2025 edition of NFPA 72, specifically within Chapter 29, to help address some of the issues that we've shown here with applicability and some confusion between when Chapter 29 is applicable and whether or not low frequency smoke alarms are required within some of these other occupancies, and trying to make it more of an enforceable edition of the code. So look for that to be coming out in the 2025 edition. And as well, or as always, if you see anything that needs to be addressed, please get involved, submit a PI, do what you can to help us address some of these issues in the codes. So.
Great, Corey, Richard, thank you. So Richard, back on your smoke alarm statement there, in one of our future presentations, we're going to talk a little bit about some of the newer technologies, but is a lot of this tied to the development of the power supply and the battery necessary to support the audibility?
As usual, you're 100% correct. What I call the traditional 3 kilohertz signal, all right, was whether it was an integral sounder for a smoke alarm or a fire alarm system horn, it used this electronic component to produce the audible signal. And it, for the most part, had very low current draw. But, for the low frequency sound, you can't use that little electronic component. So it draws considerably more current or power than that little 3 kilohertz electronic component. So what does that mean? For the smoke alarm manufacturers, for new construction, you got to have 120 volt with battery backup. And that battery backup, you got to have a pretty good, huge battery there to run that, in the event of a power outage. So that's really the main challenge that the smoke alarm manufacturers have to overcome. But there have been some changes to the UL 217 product standard that should help the smoke alarm manufacturers produce that signal, which I think will be addressed in one of the upcoming webinars.
No, that's great. That's you nailed it. Thank you very much. So again, thanks everyone for participating. I'd like to specifically thank Richard and Corey for their great information. I look forward to the continuation of this at the symposium. And again, we'll be posting all this information to the IFC site once we have the symposium. And again, if you have any questions, please don't hesitate to email us, and we'll be glad to get those answered for you. This recording webinar will be available here in the next 24 hours. And as soon as we close out the webinar, you'll receive a survey just asking you about the webinar and other future webinars that we should have. And please help us help you with giving us your thoughts and where we need to go next with this event. And again, special thanks to Richard and Corey, National Home Builders Association and Fire Life Safety Section for sponsoring this webinar series from IFC Webinars. And this concludes today's event. Thank you.